Space, an endless void whose secrets are still unknown to science. A flawless system of billions of galaxies and the stars, planets, comets, asteroids, and clouds of gas and dust all moving together in perfect harmony. And the Milky Way, the giant star system of which our solar system is a part. We shall soon be examining this magnificent system from one end to the other. Our journey will begin from the very furthest planet from our Sun. Pluto, the furthest planet from the Sun. A world of rock and terrifying cold. Its surface temperature is around -238 degrees centigrade. Under the influence of that freezing cold, even the thin atmosphere of this planet is turning into a block of ice. A dead mass of ice. Neptune, another frozen planet. Surface temperature -218 degrees centigrade. The atmosphere, consisting of hydrogen, helium, and methane, is poisonous to life. The high levels of poisonous methane give its atmosphere a blue color. This is a deadly world, racked by terrible storms moving at up to 2,000 kilometers an hour. Uranus, a dead planet, largely consisting of rock and ice. It takes Uranus 84 Earth years to orbit the Sun. Its atmosphere of hydrogen, helium, and methane is fatal to life. Saturn. This is the second biggest planet in our solar system. It is particularly well known for the system of rings encircling it. These rings are made up of gases, rock, and ice. The planet itself is composed entirely of gas, 75% hydrogen and 25% helium. Its density is less than that of water. Jupiter, the biggest planet in the solar system. Also a gaseous planet. It is 318 times the size of Earth. This large red mark is a storm large enough to hold 2 of our Earths. There is no land on it. An insane cold, terrible storms that last for hundreds of years. A magnetic field that could kill any living thing. A dreadful and frightening planet. And Jupiter's satellite, Io, covered in volcanoes. It acts as an electrical generator as it moves through Jupiter's magnetic field, developing 400,000 volts across its diameter. Mars. Its atmosphere is a poisonous mixture with high levels of carbon dioxide. Its surface is full of craters caused by striking meteors and deep valleys hundreds of kilometers long. a ball of red rock ruled by violent winds and sandstorms that go on for months. Venus. Unlike the freezing cold of the other planets, Venus is a giant oven of burning temperatures. The temperature on its surface is enough to melt lead, around 450 degrees centigrade. It has a heavy atmosphere made up of a thick layer of carbon dioxide. The atmospheric pressure on this planet is equivalent to that found on Earth at 1 kilometer below the sea. Its atmosphere is covered with layers of sulfuric acid kilometers high. The planet is therefore constantly subjected to lethal acid rain. Nothing can live in such an atmosphere. Mercury, the nearest planet to the Sun. It spins around its own axis very slowly. Since its days and nights are very long, one face glows red and the other freezes. Such an environment would be fatal to any living thing. As this short journey has shown us, 8 out of the 9 planets in our solar system and all their 53 moons are incapable of sustaining life. Each one is dead, a mass of silent rock and gas. However, one planet in this system, one that we have not looked at yet, is very different from the others. Because all its features, from its atmosphere to the makeup of its surface, from the temperature to its magnetic field, and from its elements to its distance from the Sun, have been created in the best manner for sustaining life. That planet is our Earth. Unlike its neighbors in the solar system, the Earth is a planet full of life. There is a most harmonious balance of life in the sky, on the land, and in the seas. Millions of animals, plants, insects, and sea creatures, all with different structures, colors, and features, live together on this special planet. This great equilibrium on Earth and all the living things on it are proofs of the existence of God and the artistry of His creation. God invites mankind to consider these things in one verse of the Quran. It is God who created the heavens with no support. You can see them, and cast firmly embedded mountains on the earth so that it would not move under you, and scattered about in it creatures of every kind. And we send down water from the sky and make every generous species grow in it. This is God's creation. The survival of life on Earth is as great a miracle as its creation. That survival has been brought about by very special conditions ideally designed for life. Even the tiniest alterations in these conditions could lead to terrible disasters. Yet in the absence of any intervention from outside, no such thing will happen. The blue planet was miraculously created with an unimaginable number of special features to maintain life on it. Thanks to these features, and unlike its neighbors, it offers an extraordinarily beautiful place in which to live. During the minutes that follow, we shall be looking at some of these miraculous features of the blue planet and seeing how they totally invalidate the materialist thesis of chance. We shall witness the great wisdom and might with which God created our world. Temperature and atmosphere are the first essential factors for life on Earth. The blue planet has both a temperature that is inhabitable and an atmosphere that is breathable for living things. These two extremely different factors, however, have come into being as a result of conditions that turn out to be ideal for both. One of these is the distance between the Earth and the Sun. Earth could not be a home for life if it were as near the Sun as Venus is, or as far from it as Jupiter. When one considers the universe as a whole, coming across a range of temperatures as narrow as this is quite a difficult task. Because temperatures in the universe vary from the millions of degrees of the hottest stars to absolute zero, which corresponds to a temperature of minus 273 degrees Celsius. In such a vast range of temperatures, the thermal interval that allows life to exist is slim indeed. But our planet Earth has it. The American geologists Frank Press and Raymond Siver draw attention to the average temperatures prevailing on Earth. They note that life as we know it is possible over a very narrow temperature interval. This interval is perhaps 1 or 2% of the range between a temperature of absolute zero and the surface temperature of the Sun. The maintenance of this thermal range is also related to the amount of heat that the Sun radiates, as well as to the distance between the Earth and the Sun. According to calculations, a reduction of just 10% in the Sun's radiation energy would result in the Earth's surface being covered by layers of ice many meters thick, and if that were to increase by a little, all living things would be scorched and die. Not only must the average temperature be ideal, the available heat must also be distributed fairly equally over the whole planet. A number of special precautions have been taken to ensure that this in fact happens. The Earth's axis is tilted at an angle of 23 degrees 27 minutes in relation to the plane of the Earth's orbit around the Sun. This inclination prevents overheating of the atmosphere in the regions between the poles and the equator. If this inclination did not exist, the temperature gradient between the poles and equator would be much higher than it is, and the temperature zones would not be so temperate or so easy to live in. The rotational speed of Earth on its axis also helps keep the thermal distribution in balance. The Earth makes a complete rotation once every 24 hours, with the result that alternating periods of daylight and darkness are fairly short. Because they are short, the thermal gradient between the light and dark sides of the planet is quite modest. The importance of this can be seen in the extreme example of Mercury. As the rotational speed of Mercury on its axis is so slow, a day lasts longer than a year, and the difference between daytime and nighttime temperatures is almost 1,000 degrees centigrade. This terrible temperature difference would allow nothing to live. Geography also helps to distribute heat equally over the Earth. There is a difference of about 100 degrees centigrade between the polar and equatorial regions of Earth. If such a thermal gradient were to exist over a completely level area, the result would be winds reaching speeds as high as 1,000 kilometers an hour, sweeping away everything in their path. Instead, the Earth is full of geographical barriers that block the huge movements of air that such a thermal gradient would otherwise cause. These are chains of mountains. At the same time, there are a number of auto-control systems that help keep the atmospheric temperature in balance. For example, when a region heats up, the rate at which its water vaporizes increases, causing clouds to form. These clouds reflect more light back into space and make rain fall. This prevents both the air and the surface below from growing warmer. The mass of the Earth is no less important for life than its distance from the Sun, its rotational speed, or geographical features. Looking at the planets, we see a great range of masses. Mercury, for instance, is only 8% of the mass of the Earth, while Jupiter is 318 times bigger. Is the size of Earth as compared with other planets coincidental, or is it deliberate? When we examine the dimensions of the Earth, we can easily see that our planet was designed to be exactly the size it is. American geologists Frank Press and Raymond Siever comment on Earth's fitness. And Earth's size was just about right. Not too small as to lose its atmosphere because its gravity was too small to prevent gases from escaping into space, and not so large that its gravity would hold on to too much atmosphere, including harmful gases. In addition to its mass, the interior of Earth is also specially designed and consists of layers with various features that go round down to its core. These layers are in motion and form a special magnetic field. It is this field that allows us to navigate by means of a compass, or for migrating birds to find their destinations. What is more, this field that extends even beyond the atmosphere also forms a protective shield that defends the Earth from dangers that might come from space. The majority of the lethal cosmic rays and meteors that travel around in space are unable to penetrate this protective shield that surrounds the Earth. The greater part of the plasma clouds formed by solar explosions are deflected by this magnetic field. The remainder, a very small amount in any event, are diverted to the polar regions, which are in any case ill-suited to life. The particles striking the atmosphere in this region form a magnificent light display in the sky. If this protective shield did not exist, life would be destroyed by harmful radiation, and might not even have come into existence at all. Yet thanks to this magnetic field, formed by the core of our planet, the Earth possesses a magnificent defensive shield. God has reminded people of this fact in the Quran. We made the sky a preserved and protected roof, yet still they turn away from our signs. Earth's physical features, mass, structure, temperature, and so on, are just right for life. Such features alone are not enough to allow life to exist on Earth, however. Another vital factor is the composition of the atmosphere. Science fiction films sometimes mislead people. One example of this is the suitable atmospheric conditions that are frequently encountered in these films. Astronauts approaching a distant planet in their spacecraft look to see whether the atmosphere is breathable or not before landing. When the computer on their ship reports that the atmosphere is suitable, there is no need for any further protective measures. These scenarios give people the impression that mankind could easily and randomly find suitable atmospheres. If we could explore the real universe, we would discover that this is not true at all. The possibility of another planet's having an atmosphere that we could breathe is minute.
LC-56.
That is because the atmosphere of the Earth is specially designed to support life in a number of crucial ways. Even a short way beyond this atmosphere, it is impossible to survive without protective clothing. The atmosphere of Earth is composed of 77% nitrogen, 21% oxygen, and 1% carbon dioxide. Let's start with the most important gas, oxygen. Oxygen is vitally important to life because it enters into most of the chemical reactions that release the energy that the complex life forms like human beings require. The interesting aspect of this is that the percentage of oxygen in the air we breathe is very precisely determined. In his book, Nature's Destiny, How the Laws of Biology Reveal Purpose in the Universe, the famous professor of microbiology, Michael Denton, writes, "Could your atmosphere contain more oxygen and still support life? No. Oxygen is a very reactive element. Even the current percentage of oxygen in the atmosphere, 21%, is close to the upper limit of safety for life at ambient temperatures. The probability of a forest fire being ignited increases by as much as 70% for every 1% increase in the percentage of oxygen in the atmosphere. The fact that the proportion of oxygen in the atmosphere remains at this precise value is the result of a marvelous recycling system. Animals constantly consume oxygen and produce carbon dioxide, which, for them, is not breathable. Plants do just the opposite. They take in carbon dioxide, which they need to live, and release oxygen instead. So life goes on. Plants release millions of tons of oxygen into the atmosphere every day. Without the cooperation and balance of these two different groups of living things, our planet would be uninhabitable. For example, if living things only took in carbon dioxide and released oxygen, the Earth's atmosphere would support combustion much more easily than it does, and even a tiny spark could set off enormous fires. Similarly, If both took in oxygen and released carbon dioxide, life would eventually die out when all the oxygen had been used up. However, the balance of life has been so perfectly set up that the oxygen in the atmosphere is always at the ideal level for life. A balance so flawlessly designed and that remains so perfect at every moment shows once again the infinite knowledge and power of its creator. That Lord of all the universe, the creator of the heavens and the earth, is the Almighty God. God calls on man to consider this truth in a verse from the Quran. Do you not see that God has subjected you to everything in the heavens and earth, and has showered His blessings upon you, both outwardly and inwardly? We breathe every moment of our lives. We constantly take air into our lungs and let it out again. We do it so much that we might think of it as normal. In fact, respiration is quite a complex process. Our bodily systems are so perfectly designed that we do not need to think about breathing. When we inhale, oxygen floods into about 300 million tiny chambers in our lungs. Capillaries surrounding these chambers absorb the oxygen and release carbon dioxide. The whole thing takes less than half a second. Clean oxygen comes in and dirty carbon dioxide goes out. The reason why there are 300 million of those little chambers in the lungs is to maximize the surface area that is exposed to the air. There is another point here that we need to keep in mind. The chambers of the lungs and the capillaries surrounding them are designed this small and perfectly in order to increase the rate at which oxygen and carbon dioxide are exchanged. But that perfect design depends on other factors. The density, viscosity, and pressure of air must all be right in order for the air to move properly in and out of our lungs. An example will help us to understand this more clearly. It is easy to draw water up with a syringe, but it would be a lot more difficult if we tried to draw honey up instead. That is because honey has a higher viscosity and is denser than water. If the density, viscosity, and pressure of air were higher, breathing would be as difficult as drawing honey into a needle. Whereas we are able to breathe perfectly comfortably without even being aware we are doing it. The factor that makes breathing so easy is the atmosphere's features and arithmetical values. Molecular biologist Professor Michael Denton makes this comment. It is clear that if either the viscosity or the density of air were much greater, the airway resistance would be prohibitive, and no conceivable redesign of the respiratory system would be capable of delivering sufficient oxygen to a metabolically active air-breathing organism. By plotting all possible atmospheric pressures against all possible oxygen contents, it becomes clear that there is only one unique tiny area where all the various conditions for life are satisfied. It is surely of enormous significance that several essential conditions are satisfied in this one tiny region in the space of all possible atmospheres. The arithmetical values of the atmosphere are not only necessary for us to breathe, but are also essential for our blue planet to stay blue. If sea level atmospheric pressure were much lower than its present value, the rate of water vaporization would be much higher. Increased water in the atmosphere would have a greenhouse effect, trapping more heat and raising the average temperature of the planet. On the other hand, if the pressure were much higher, the rate of water vaporization would be less, turning large parts of the planet into desert. The examples we have seen throughout this film show that the Earth was specially created for life. The things we have mentioned so far are just a few of the delicate balances that are essential for life on Earth. Examining the Earth, we can make the list of these miraculous features as long as we please. The American astronomer Hugh Ross has made a list of his own in his book, The Creator and the Cosmos. Surface gravity. If stronger, the atmosphere would retain too much ammonia and methane. If weaker, the planet's atmosphere would lose too much water. Thickness of the crust. If thicker, too much oxygen would be transferred from the atmosphere to the crust. If thinner, volcanic and tectonic activity would be too great. Rotation period. If longer, diurnal temperature differences would be too great. If shorter, atmospheric wind velocities would be too high. Ozone level in the atmosphere. If greater, surface temperature would be too low. If less, surface temperatures would be too high, and there would be too much ultraviolet radiation at the surface. Seismic activity. If greater, too many life forms would be destroyed. If less, nutrients on ocean floors from river runoffs would not be recycled to the continents through tectonic uplift. These balances, of which we have cited only a few examples, once again demonstrate that materialism, which maintains that the universe came into being by chance, is a great deception. The evidence revealed by science shows that God created the entire universe and all living things. Man's duty is to consider these points and give thanks to God, who created him and the entire universe. In one verse of the Quran, God addresses people in these terms. It is God who made the earth a stable home for you and the sky a dome, and formed you, giving you the best of forms, and provided you with good and wholesome things. That is God, your Lord. Blessed be God, the Lord of all the worlds.